The 5.1 quick check is really checking up on two things. One is, can you classify reactions, and then balance equations. But in addition to that, it calls upon all of your understanding about ionic compounds and covalent compounds and diatomic elements and things to put together the equations. So we start with a word equation and then develop the written equation. So let's get started. So first thing here says solutions of silver nitrate and potassium chromate are combined to form aqueous solutions of potassium nitrate, silver chromate. So you can see that the silver is with the nitrate, and then the potassium is with the chromate, and then they switch partners, so we have the silver with the chromate, and then the potassium with the nitrate. So that should be a big clue that this is a double replacement reaction. And when we get started writing it, the first step is we have to go back and say, okay, what are these ions? We should know that silver is Ag+, nitrate is NO3 1-, potassium is K+, and chromate CrO4 2-. Now we have to write the compounds, so silver nitrate would be AgNO3, one of each. And we have potassium chromate +1 and a -2, and so this is going to be K2 CrO4. Now that turns, we're going to switch partners. We're going to get Ag+ going with the chromate, so that's going to be Ag2. Well, we'll just do the potassium nitrate first. So K+ and NO3- would be KNO3. And because the silver and chromate go together, +1 and -2, this is Ag2 CrO4. Now, to balance this equation, we can say, well, here's Ag2 CrO4, so we need 2 of the AgNO3s. If we have 2 NO3s, we'll need 2 KNO3s, and we have 1 chromate and 2 potassium. So this is our balanced equation, 2, 1, 2, and 1. And some people don't do this middle step, and I can kind of predict that if you don't do that step where you look at the ions, people come up with the wrong compounds, especially over here in the product sign. So be very careful to stop and do that in-between step. Now the next one here for propane. Well, propane we know is C3H8. And it's burned in air. So just the fact we're burning it, that tells us this is a combustion reaction. We need to react with O2 because oxygen is diatomic. The carbon reacts with the oxygen and becomes CO2. The hydrogen reacts with the oxygen and becomes H2O. Now to balance, we go back and say we got 3 carbons, so we can make 3 CO2s. So we just look at one element at a time. We started with the carbon, so 3 carbons means 3 CO2s. 8 hydrogens, that means we could make 4 H2Os, that would be 4 times 2, 8 hydrogen atoms. And then on the right side, on the product side, we'll say, well, how many oxygens? 3 times 2 is 6, 4 times 1 is 4. We have 10 oxygens in total. So on this side, we have 10 oxygens, that would be 5 O2s. So our balanced equation is 1, 5, 3, and 4. Now, the next one here, solid iron filings. Okay, solid iron filings, that's going to be iron, Fe, we know that. But the fact that it's solid, then that means that's the neutral iron, not Fe2+ or Fe3+, just neutral iron. We're adding that to oxygen gas. We know that that's diatomic. And it's forming solid iron 3 oxide. So the name lets us know we're talking about Fe3+, ferric, and O2-. So the compound here is going to be Fe2O3. Now, to finish this off, we say, well, here we have 3 O's on this side and we have 2 O's on this side. So to balance, we can kind of say, well, it's going to be easier to balance the oxygens first and then everything else will fall into place. So if I want to balance 2 with 3, I'll put a 3 in front of the O2 and a 2 in front of the O3, and that would give me 4 Fe's, and that would be my balanced equation. A solution of hydrogen peroxide decomposes to form water. We're just supposed to know that hydrogen peroxide is H2O2. We've seen that in the reactions that we did when we were doing the cabbage lab. So H2O2, and it decomposes to form water, and everybody knows water is H2O, and oxygen gas, and here we know that oxygen is O2. Now, as a quick side note, if you didn't really know that hydrogen peroxide was H2O2, a big clue is that we did memorize the ion O2 2-, and we did memorize the hydrogen ion H+. And if you put those two ions together, you do get the compound H2O2. But H2O2 is not an ionic compound. We tested that in the lab, and we saw that it is a non-electrolyte, does not conduct electricity, so there are no ions. But this does give you the correct answer. Now to go back and balance, we see we have oxygens in all three compounds here, all three substances, so we do not want to go with the oxygens. We'll look at the hydrogens, and we can see 2 hydrogens on this side, 2 hydrogens on this side. So whatever the coefficient is going to be, it's going to be the same for both sides. So it might be an idea to go ahead and say 1 here and 1 here. Then we get into trouble because we have 2 oxygens. Here we have 1. We need 1 oxygen here. So one idea is to go back and say 1/2 O2. So 1, 1, and 1/2. That would balance the equation, but we would rather go back and not use the equation, not use the fractions, and we'll say let's make this a 2 and make this a 2, and then we have 4 oxygens on the reactant side, and just right here 2, 2, and 1. That'll give us a balanced equation. So 1, 1, and 1/2, or better yet 2, 2, and 1 for a balanced equation. The next one here, copper metal. Okay, copper metal is just copper Cu, not Cu+, not Cu2+, just copper 0, and it's in a solution of silver nitrate. I'm sorry, I didn't go back here. This reaction here, it says decomposes. That's a big giveaway that this is a decomposition reaction. That's kind of a no-brainer. Okay, back here, copper metal placed in a solution of silver nitrate. Now we saw this a moment ago, Ag+, NO3, 1-, so 1 + 1-, the compound is AgNO3. And when we see that we have an element combined with an ionic compound, that's going to be single replacement. Now the copper replaces a silver, and that's a clue because we know copper forms a copper positive copper ion, and in this case it tells us it's copper 2+. So since copper forms a +2 ion, we should know that it's going to replace the silver. And so we get copper nitrate, Cu2+, and NO3, 1-. So we have 2 of these. And it says silver metal, so we just have Ag, not Ag+, just neutral Ag. So the metal here tells us that those are neutral elements. So copper plus silver nitrate, silver plus copper nitrate. Now to balance, we have 2 nitrates over here. So let's go ahead and put a 2 in front of this. That gives 2 silvers. We need 2 silvers, and now we have a balanced equation. Okay, the other part of the problems here, predict the products. So synthesis of dinitrogen trioxide. Just the name tells us that that is 2 N's and 3 O's. And if we're synthesis of this, then that means we are talking about making this compound from its elements. So nitrogen, we know that is nitrogen N2 diatomic. Oxygen is O2 as well, and it's going to make N2O3. And like we saw a moment ago, if we wanted to balance this, the 3 O's and the 2 O's, we can get that to balance first. So let's put a 3 in front of the O2 and a 2 in front of the N2O3. That'll give us 6 oxygens on both sides, and we can see we're going to have 4 N2s. That is wrong. We're going to have 2 N2s, 4 N's total. Okay, so 2 times 2, 4 nitrogens, 2 times 2, 4 nitrogens. There's our balanced equation. The decomposition of potassium oxide. Okay, we think about that. K is K+, oxygen is O2-. We're going to decompose it, so we start off with K2O. And when we see decomposition, then that means it decomposes into its elements. Okay, potassium is just a metal. It's just going to be K by itself. It's not diatomic. But oxygen is one of our diatomic elements, so we know it's going to be O2. So I would start with the O's, and we can see that we're going to give 2 O's on the right side, so we're going to have 2 K2Os to get the O's to balance. Now for the K's, we have 2 times 2, 4 K's on the reactant side, we'll have 4 K's on the product side. Okay, the last one here, combustion of methanol. Okay, methanol C3CH3OH. Now combustion means burning, and in air that means mix it with oxygen. The carbon and the oxygen make CO2. The hydrogens and the oxygens make H2O. Now again, we will look at one element at a time. Start with carbon, 1 carbon, so we can make 1 CO2. Then on this side we have 3 plus 1, 4 hydrogens, we can make 2 H2Os. Then on the product side we have 1 times 2, we have 2 oxygens here, 2 times 1, 2 oxygens here, 4 oxygens total. So this is 4 oxygens, but we notice there's 1 right here, so this oxygen here must represent the other 3. Now that's a little bit tricky, so one thing we can do is we could call this 3/2 O2, or we could go back and do the whole thing again and just double everything. So we'd say 2 CH3OHs plus 3 O2s turn into 2 CO2s and 4 H2Os. And we'd have a nice balanced equation. So that's how we do the quick check.